Hello, bachcho. Hello, kids. How are you all doing? Can you see me and hear me? Come on, quickly tell me in the chat box. Hello, kids. How are you all doing? Can you see me and hear me? Come on, quickly tell me in the chat box. Just a second. Who is Puneet? Just can you call him Puneet? Hello, can you hear me? Yeah.
Are you asking for Puneet?
Yeah, it's done now. Done.
It's done.
Yeah. Okay. Okay. Hello again. This is Vipul Arora, your master teacher of physics at Vedantu. I am also a senior director of academics at Vedantu. I am here to continue with our learning which we are doing for NEET 2026. So let us start without wasting any time. Let us start with our learning, with our studies. And in the end of today's class, I am going to also tell you one thing which is coming for you guys so that you can get very good marks in the NEET 2026 examination. Okay, so let's start. So today we are going to start with our work, energy and power. It's a class 11th concept which is a very important concept for NEET examination. This concept is not only important in its own self, but it is also important because it is going to be utilized in so many chapters in class 11th as well as in class 12th. Because when we talk about work, when we talk about energy, when we talk about power, we will use all these things in the chapter of electrostatics, in the chapter of electromagnetic induction, in the chapter of rotation, even in the chapter of thermodynamics, KKG and thermodynamics as well. So it is going to be utilized so much. So that's why this chapter is a very crucial chapter for you to learn and to understand. Okay, so let us start. So first of all, when we talk about work, energy and power chapter, we will start with the concept of work. So what is this work? So whenever we talk about the concept of work, one thing you must remember is work done by a force. So first thing that should come to your mind is that what is the force due to which you are required to find the work done. That is step number one. Secondly, on which particle or body the work is being done by that force on which particle or body work is being done by that force. And in order to calculate the work, you need to know how much displacement has happened of that body or that particular particle on which we are finding or trying to find the work done by the force. Okay. So, three things: which force is responsible for that work done, on which particle or which body we are trying to find the work done, and the displacement of the particle or the body So these three things you have to think in order to find the work done. See, if you are able to get these 3 points in your mind clearly, then you will find that it is very easy for you to get the answer of any question to find the work done. And there's also, very less probability of making mistake in such scenarios because you are clear. Otherwise, what happens? I have seen from so long that many students does mistake in these kind of question because they don't pay attention to the point because of which force the question has asked for finding the work done, or they don't even sometimes they miss the displacement of which body they are interested in, or on which particle the work is required to be done. They also miss that. I'll take some examples to make you understand this as well. Okay. Now mathematically I will say work done is equal to F vector dot with ds vector. So this is the small work done due to this force vector, and when the displacement is small ds vector. So ds vector is the small displacement, F vector is that force, and dw is the small work done due to that force. Now if I have to find the work done for a finite displacement, so this is the basic definition. So if I just write, let's say this is the body, this is the force acting on this, and as a result there is a small displacement here of this body. So this work done is F vector dot with ds vector for this small displacement. But if displacement is bigger, that means you have to integrate to get the total work done. So the general definition of the work done calculation is integration F vector dot ds vector. That is the point number 1 for you to take home. Okay. Now, after this definition, we are going to talk about that how it is calculated for different kinds of forces. So maybe the forces may be constant or the forces may be variable. So if it is a constant, you will find that life is simple. But if the force is variable, then you will find that it will be a little difficult, but still after integration, you will get the answer very easily and very quickly. Okay, let's take a step ahead. So we will start with the concept of work done by a constant force. So whenever we talk about this constant force work done, can you see from this definition, if you see this F vector, because it's a constant, it will come out of the integration and you are left with integration ds vector. So you can see because of a constant force, the work done is given by F vector dot with s vector. So F vector dot with s vector, this dot is the dot product of the force vector and the displacement vector, force vector and the displacement vector. Obviously, we all know the dot product we can write as F into S into cos theta, where theta is the angle between force and displacement vector. Angle between F vector and S vector. Now, just to show you in the form of a diagram, let's say you have a constant force whose magnitude and direction will remain constant throughout. Let's say this is S vector, this is theta. So the work done is Fs cos theta. Please remember, work done is a scalar quantity, although it can be positive, negative or 0, but it is a scalar quantity. Keep that in mind because there is no, this is a dot product. So in the dot product, the answer is a scalar quantity. The unit is joule. For this work done, the unit is joule. Okay. So is this point clear till now? It is just the definition I have talked about, F into S into cos theta. Now, after this point, now we are going to take up few examples of the constant forces which we encounter in our questions, like in Newton laws of motion, in friction, and then use them to solve the questions. Okay. So whatever I have written for you, this is also there in the printed form, so that when you get the notes of this class, you also have a printed notes with you. Okay. Now, once we know the concept of work done by a constant force, now the interesting point is, if I say, okay, so before I just take, let me just take an example first. Okay. Let's say you have a block and you are applying a force F vector whose magnitude is, let's say, 20 Newton. And as a result of which there is a displacement of, let's say, 5 meter in this direction, such that this angle is theta is equal to 60 degrees. So can you quickly tell me the answer in the chat box? What will be the work done in this scenario? It's a very simple question. I just want to see how many of you are actually solving the question in the class. Quickly solve it. I am just looking at your answers in the chat box. Come on. Bachon, give the answer quickly. Yes, beta, displacement is a vector quantity. Kampa, displacement is a vector quantity. Force is a vector quantity, but the dot product is a scalar quantity. Okay. I am good, beta. Sanyam. Come on. Very good. Sanyam has given the answer. What about others? Very good, Kampa. So if you see, it is F S cos theta, which is the work done. F is 20 Newton magnitude, S is 5 meter, and cos of 60 degrees. So you get cos 60, you should know cos 60 is half. So you get 20 into 5 into 1 by 2, which is 2 tens are 20, and which is 50 joules. So the work done came out to be 50 joules. So what I'm trying to say here is that if you know the force, if you know the displacement, and you know the angle between force and displacement, see how quickly you got the answer. But in the same question, if I just change the data a little bit, I'll just give it here only. Let's say you are applying a force here and the displacement happened in this way. Please understand, there might be other forces, but we are only interested in finding the work done due to this force only. Please understand, we are finding the work done due to this force only. So let's say the magnitude of this force is same, 20 Newton. This displacement is 5 meter. And let's say this angle is now 120 degrees. Now, can you tell me what will be the answer of work done in this scenario? Can you please quickly tell me? Kampa, Sanyam. Come on. Quickly tell me. Rakhi. Devika, come on. I am waiting for your answers. Come on. Very good, Sanyam. Now the answer is minus 50 joules. Why the negative sign came? Because see, you did work done by the force F is equal to F into S into cos theta. Now you can see it is 20 into 5 into cos of 120 degrees, because now the angle between force vector and the displacement vector is 120 degrees and cos 120 is minus half. So you get answer as minus 50 joules. Now some people might be wondering, sir, work done being negative, what is the physical feeling of that? See, work done positives, people generally don't ask questions. But work done being negative, what is the physical feeling? So we are going to talk about both the feeling of work done being positive and work done being negative. But before that, one more question, and I hope now you can actually guess the question which I am going to ask. Let's say this person is applying a force on this wall. Okay. And this wall is stationary and it does not move. So this force F. Question is, find the work done by the person or by the force applied on by the person on the wall. So I think you can clearly see that there is no displacement of the wall. So work done is just 0 because there is no displacement. Okay, so that means work done can be 0 also, it can be positive also, it can be negative also. Okay, now the interesting point here is there is also one more way in which we can show that the work done is also possibility of 0. I'll just take an example before I tell you the physical feeling of how what is the physical feeling of work done being negative, work done being positive, and so on. Let's say you have a particle in a circular motion and this particle is going like this of length L. It is moving in a circular motion. It's a string here. So you can see one thing very clearly, that the force on this particle is in this direction. And at any instant, if you see, the small displacement of this particle is along the tangent, because I am talking about small displacement. So you can see that the angle between the force vector and the small displacement vector is 90 degrees. And therefore, if when you say the work done by tension on this particular particle, it is given by T ds cos 90. And this will become 0 because we know cos 90 is 0. So interestingly, in the circular motion, the force which we call as centripetal force, the necessary force which is necessary for requirement for circular motion to occur, that force is what we call as centripetal force. So the work done by the centripetal force on the particle undergoing circular motion is always 0 because the angle between the centripetal force and the small displacement at any instant is 90 degrees, and therefore cos 90 is 0, and therefore the work done by centripetal force on the particle undergoing circular motion is 0. Okay, keep this in mind, it will be very helpful. Okay. Now, so what is the question or what is the physical feeling I want to develop here in your mind? Okay. So basically what I want to tell is, when we say that the work done by a force is positive, so mathematically when theta is acute, work done is positive. When we say work done is negative, when theta, that is the angle between the two force vector and the displacement vector, is obtuse, then the work done is negative. So physical feeling is, when the work done by a force on a particle is positive, it physically means that the energy is being transferred by the agent who is applying the force to that particle or to that body. So energy is transferring to that body. By whom? By the agent who is applying that force. Just for example, let's say you have a box in front of you and you are pushing, and this box is developing some velocity because you are pushing it. Now can you imagine that I am the person who is applying the force, and as a result this block is moving in the right direction, in the same direction as the force, and in this scenario work done come out to be positive. So this will lead to increase in energy of the body because I am giving energy to that body because I am doing positive work done. Now on the same way, if the work done by the person on a body is negative, what does it physically means? It physically means that this person is getting energy from that particle or from that body. A clear way to feel this kind of thing will be, I'll show you, just to show that negative work done feeling. See, for example, this is a spring. Okay. Now, if I am pushing this, so what I am doing as a person, I am giving energy to this because the displacement is also in this direction, force is also in this direction. So I am doing positive work on this. So energy by the person is being transferred to the block. Now what will happen to the block, that's a different issue. Now if you see it from a slightly different perspective, same question, this is displacing in this direction, but I hope you remember for the spring, if the spring is compressed from its natural length, the spring is going to push it back, or it will apply a force in the backward direction. So this spring force is being applied on the particle in this direction. Now try to develop a feeling. The work done by spring on the block in this situation is negative. So work done by the spring on the block is negative. Now see the physical feeling. This spring is getting some energy from the block. And what is it doing with that energy? It is storing in its spring potential energy, which we'll talk about a little later. But the feeling which I want to develop here is that, and the work done being positive, meaning energy is being transferred to the particle or the body. Work done by a force being negative, it means that energy is being taken away by that particular force from that particle or from that body. And if it is zero, it means no energy transfer is taking place. Please do take this point home because this is important for your physical understanding of the concept. Just to ask you if you have understood this or not, can you tell me if this block goes from here to here and this is a rough surface, and as a result of which there is a kinetic friction Fk acting on this. Just tell me the work done by friction on the block is positive or negative. Tell me in the chat box. I am waiting. Tell me in the chat box if it is positive or negative. Come on, come on. Work done by the friction on the block. It is negative. Reason? You can see force and displacement are in opposite direction. Angle between them is 180. So F into S into cos of 180, which is negative. So that is why the work done in this scenario will be negative. Okay. So keep this in mind. So let us now take a step ahead. So positive work done, negative work done, mathematically calculation of work done, we can easily do. Can work done be zero? Answer is surely yes. Work done can be zero. We have just seen a few examples for that, right? So this thing also we have done. Now, interesting point is to calculate the work done. See, sometimes we require forces, displacements and angle. Obviously, we can also do to find work done using the force vector and the displacement vector and using the dot product. So let me take one question before that thing. Let's say we have a force given by 2i cap minus 3j cap plus 5k cap. And the displacement vector of the particle, let's say, is I cap plus j cap plus 3k cap. Now the question is, what is the work done by this force in this displacement? So the answer will be F dot S. So can you give me the answer? Rudirun, can we give the answer, beta? Sanyam? Kampa? Kampa is Rudiran only. Come on, come on. Give the answer, bacho. F dot S. You just have to use the dot product. So I hope you remember I cap with I cap, it is giving you 2 minus 3 plus 15. 17 minus 3 is 14. So the answer is 14 joules. So sometimes depending upon how they have given the question, you can use or calculate the work done using F dot S as well directly. Then you don't have to do F magnitude, S magnitude into cos of angle between them. You can directly do it in this manner. Okay. Now, okay. Now, sometimes we can also do a question in which they have given, instead of giving us the mathematical function of the force, or instead of giving us the physical force, they may have given a mathematical graph of the force. So mostly you will find that in such a scenarios, they will give us straight lines in the graph, because then it is easy for us, or then it is possible for us to calculate the area of triangles, area of trapezium in that particular scenario. Because if you see, the work done was f vector dot with ds vector and the integration of that. See, I can write this as fx dx, because we know the dot product formula, fy dy plus fz dz. Now we just have to integrate this expression, fx dx, fy dy, fz dz. So if you have only one dimension force, so then you just take one of them. If you have all the three dimensions, you take all the three. So generally for one dimension, we'll just write integration f dx. That's what we generally do. And from some x initial to some x final. That's how we calculate the work done, let's say in x dimension, if the force is only in the x dimension. Okay. But please remember, if you have forces vector along x component also, y component also, and z component also, then you have to add these three things simply, like integration fx dx, integration fy dy, integration fz dz. Please remember, it is not a vector quantity finally. These are scalar quantities and you have to calculate them accordingly. Okay. Now, how to actually go ahead? If you see, integration f dx is nothing but the graph or the area under the graph from x initial to x final for this particular function of force. So what you only have to do, you only have to find the work done using the graph when they give you the graph. Okay. So let us take a step ahead and let us take a few examples to understand this more clearly. Okay. But before that, this is a concept of this f versus x, the area concept. The area concept is the area above the x-axis is positive and the area below the x-axis is negative. Now there is a catch here, I'll tell you. Let's say 0, x1, x2. Now this, please listen to my few lines very carefully, because otherwise there is a possibility of making a mistake. See, if the limits are from 0 to x1 in this example, the area above the x-axis is positive. In this case, the limits are from x1 to x2, then the area below the x-axis is negative. But, so just to write, let me write integration, let's say 0 to x1 f dx. In this question, this is a positive answer. In this case, x1 to x2 f dx, this will be the negative answer. So you just find the area and then give an answer with a negative sign. But if they say find the work done when the particle has gone from this point x1 to this point 0, meaning it has to go from x1 to 0. So that means the lower limit is x1 and the upper limit is 0. So please remember, in that scenario, things have changed. So the area above the x-axis, instead of being positive, here it will be negative. And similarly for this thing, if it is from x2 to x1 f dx, so the area below the x-axis in this scenario will be positive instead of being negative. Please remember that this is something which can, make or, can make your rank also in the exam, because sometimes what happens, they give a question like this and many people fall into the traps in the question or in the exam. And those people get it wrong. But those who are smart and they understand things, they will do correct. I will take examples to, set this thing in your mind very clearly. Okay. Let's take example. So let's say the question is, okay, 0, let's say 10, 20, let's say 30, and this is, let's say 40. Okay, this is the force versus x. Now you guys have to answer it, okay? This will be, let's say 5 and this will be minus 5. Now the question is, work done by the force F from, now I am writing from x equal to 0 to x is equal to 20. So the point is, it is from 0 to 20. So from lower value to upper value. So area above the x-axis is positive. So the answer is plus half into base 20 into height. How much? I think was 5 into 5. So can I say the answer will be plus 50 joules? Okay. Now, if I ask you work done by this force from x is equal to 20 to x is equal to 40, can you tell me the answer quickly in the chat box? Come on. Come on, come on. Sanyam, yes, plus 50. Very good, Sanyam. So it is again plus 50. Plus nahi. In this case, it is not plus because the area is below the x-axis. It is minus. Sanyam, galti kar di beta. Sanyam, you have made a mistake. It's not plus 50 for 20 to 40. It is minus 50. So if I just write it, I'll write minus half into 20 because 40 minus 20 is 20 into 5. So you get minus 50. Now the question is, now this I think you guys have to tell me, from x is equal to 20 to x is equal to 10. Can you tell me this answer? First tell me whether it should be positive or negative. First tell me whether it should be positive or negative. Okay, beta Sanyam. Come on, whether it is positive or negative from 20 to 10. So first of all, you can see it is from this point to this point. That means from higher value to lower value. That means area above the x-axis is negative. So half into 10 into 5. That is the area we know because this is 5 and this is 20 minus 10 is 10. But since the limits are from 20 to 10, so higher to lower, then area above the x-axis will be negative. So the answer will be minus 25. So this answer will be minus 25 joules. Is this point clear to everyone, bachcho? This is something which is very, very crucial. Okay. Now, similarly, we can make questions. So if I just ask you from 30 to 20, then area below will be positive. Again, it will come as plus 25. Okay. So do keep this in mind. This is important for your understanding, as well as it can differentiate the kids who will get into that 720 range or 700 plus range versus those who may not be able to, because by doing this mistake. Okay. Okay, let's take a step ahead. So again, it's a simple question. Can you give it a try quickly? A body of mass 5 kg is placed through a distance of 4 meter under an acceleration of 3 meter per second square. So they have given acceleration, and why they have given acceleration? So that you can find the force. And in that scenario, you have to calculate the work done. Okay. So I'm waiting quickly. Come on, come on. Very good, smart mind vibes. Come on quickly. See, it's a very simple one. Only thing is you have to write what? See, they have given you mass. They have given you acceleration. So basically you already know force is equal to mass into acceleration, which is 5 into 3, which is 15 newtons. And this distance, since it is going in a straight line motion, we can say this is 4. So the work done will be F into S into cos 0. Cos 0 because force and displacement are in the same direction. So you get F will be 15, F will be 15 and S will be 4. So you get 60 joules. Simple, direct, quick question, and many of you already got it. Great. Let's take a step ahead then. It's a simple one, so we can go ahead. Okay. Now this is an interesting one. If you see in this, they have given two forces and they have said the particle is shifted from point 1 to point 2 under the action of F1 and F2, and they want the work done by the resultant of these two forces. So this requires some work to be done. Can you try this? Can you try this? Just tell me in the chat box if you're trying. Just write trying so that I get to know that you are trying the question. Come on. Come on, come on. Kampa, no, it's Rudirun, Sanyam, Smart White Vibes. Come on. Midhunesh, Devika, Raki, come on. Okay, so Sanyam has given some answer. Let's see. Okay, let's see. See, first important point is this is the starting point, this is the final point. So to get the displacement, you have to use 1 minus 0 I cap plus 1 minus 0 j cap plus 2 minus 1 k cap. So you get the value of displacement as 1 I cap plus 1 j cap plus 1 k cap. Now they want the work done by the resultant of two forces. So the resultant will be just the vector sum of the two forces in the vector form. Don't forget that. Now 2 I cap, 1 I cap. This will be 3 I cap. 3 j cap minus 2 j cap plus j cap minus k cap plus 2 k cap plus k cap. Now if you do the dot product F dot S to find the work done, what you get? 3 plus 1 plus 1. That is 5 joules. And that is your answer. And Sanyam has already given it. And Rudirun has also given it. Very nice. Smart Mind Vibes. Tell me, beta. Very good. Okay. So I hope you guys have understood this. Let us take another interesting thought process. So now what we know, if you see what we have done so far, we have talked about work done by a constant force. We have talked about work done by a force in a graphical form if they have given to find the area to get the answer. There we have talked about if it is above or below, positive or negative, and if the limits are opposite, then also positive or negative. So we have to be careful about these things. These are important concepts. We have to be careful about these things. Okay. Now, after that, now we are going to talk about if the force is variable. Simple, we have to do integration. Let us also go ahead and do it. So this is the answer also you have. Okay. Now there are certain questions I am giving you as homework, which you will be solving once you get the PDF of this whole notes in the description box. Okay. So this is your homework you have to do. So all the answers are there. Okay. Similarly, we have done this kind of question also. So again, you can do this. Okay. Now this is again the graph thing. So now you can find the area under the graph also to solve these kind of questions, which you can also do. Okay. If you have any doubts, you can always reach out to me, beta. I have this. This is my Telegram ID. If you have any doubt, you can always reach out to me. But you have to tell me what are your doubts and from where you are reaching out to me. Okay. Just let me know this, and just this is a Telegram ID, okay? I'll try to answer your queries, whatever you have, @Vipul Arora Physics. Okay? My name is Vipul Arora, so that's why it's @Vipul Arora Physics. Okay? Now, let's take up some questions which relates to work done by a variable force. So just to take an example, let's say you have force is equal to, let's say 3x. And I am wanting the work done by this force when x goes from, let's say x equal to 1 to x is equal to 4. This is what I want. Mathematics is simple because integration f dx. Now please remember why I am not using dot product now, because I am assuming one dimension force only, and therefore I am assuming f dx directly without any dot product, because we know it's only one dimension force. I will take an example with more than one dimensions also, but that is the next example. First, let us know how to, or let us try to solve how to get the answer if the force is one dimensional and it's a function of x, for example. So can I say this will become how much? 3x dx, x going from 1 to x going to 4. Now I will wait for you for a few seconds. Can you tell me the answer of this? It is just a simple integration. It's not a tough question, but I just want to see how many of you in the class are able to get the answer to this question. Come on, quickly. Come on, come on. Sanyam, give the answer. Rudiron, give the answer, beta. Beta, I want the final answer. Limits you have to put. That is important. That's why I gave you the question. Come on. Okay. So let's do it. This is 3 and x dx will be x square by 2, and from the limit 1 to 4. Now this will become 3 by 2 into 4 square minus 1 square. This will be 3 by 2 into 16 minus 1, which is 15. So 3 into 15 by 2, or 45 by 2. And that is your answer, 45 by 2. So simple. So if it is in one dimension, life is pretty simple. Can you see that? But if it is more than one dimension, I will tell you that is also not that difficult. Okay, it's not that difficult either. Just see. Let's say I take one more example. F vector is equal to, let's say, x square I cap plus y cube j cap. Okay, now the question is from, let's say, 0, 1 to minus 1, let's say 0. This is an interesting question, meaning this is the starting point, this is the ending point. Now how to find the work done? So I am writing work done by F is equal to, now first of all be very clear, it is by definition Fx dx plus Fy dy. Now this is equal to integration. What is the x coordinate or x component of this force? X square. And what is the y component? Y cube. You see, x square dx plus y cube dy. Now, when you are doing the integration, you have to do, now separately you can easily do x square dx, because you have to put the limits, y cube dy. Now, this is the integration over x. So the limits has to be from the, or on the x component. So you see, x is going from 0 to minus 1. And for the y, if you see, y is going from 1 to 0. Now you have to solve for them. Now can I expect you can solve it? Because there is a possibility of making mistake in this also. Let me solve it for you. It is x cube by 3, 0 to minus 1. It is y to the power 4 by 4 from 1 to 0. Now, first you put minus 1 whole cube minus 0 cube by 3. Now 0 to the power 4 minus 1 to the power 4 upon 4. You get, now minus 1 whole cube is minus 1 by 3 plus minus 1 upon 4. So the answer is, now minus common, 4 plus 3, 7 upon 12. So the answer is minus 7 upon 12. Has anyone given that? Okay, not yet, but do we understand this, everyone? Is this point clear to everyone? Okay. Chalo. Let's take a step ahead, bachon. Let's take a step ahead. So I hope you guys are able to understand how to calculate the work done when the force is constant or when the force is variable. We have to take care of the fact that if we have to use the area under the graph, then area above the x-axis positive, area below the x-axis negative in normal behavior. But sometimes they may give the lower limit as a higher value. So in that scenario, the things changes. So keep all these things in mind so that you don't make mistake. Okay. Let's take a step ahead. Okay. Again, this is an example. You can give it a try. This is an example. You can give it a try, bacho. So 0.5x plus 10, the force is acting on the particle. And here the F is in Newton and X is in meter, no problem. We have to find the work done from x equal to 0 to x equal to 2. See, the reason I brought so many questions for you is that it is the practice finally which is very important for you to get very good marks in the NEET examination. If you don't practice, there is a possibility that in the exam you will make mistakes. But if you practice quite a lot of questions, you will surely get a very good rank in your NEET examination, because you have to practice all the subjects. You have to practice physics, you have to practice chemistry, you have to practice zoology and botany as well. Because see, practice is required to get correct answers in very small amount of time. That is why this practice is important. That's why I'm doing a lot of questions here. Okay. So let's see how many of you got given the answer. Okay, very good. So many of you have given the answers, but wait. Come on. Okay, so I'm just doing it. Integration f dx from 0 to 2. This is the work done. Now f will be 0.5x plus 10 dx. 0 to 2. Now, so this will be 0.5 into x square by 2 plus 10 into x from 0 to 2. So it will become 1 by 4.5 I am writing as 1 by 2. X if I write as 2, so it will become 2 square and 10 into 2. This will become 1 plus 20. Hence the answer is 21 joules. This is your answer. Okay. So I hope this is clear to everyone. Very good, Sanyam. Very good. Okay. Chalo. Now let's take a step ahead. So correct answer is 21. Everyone got it? Okay. Now this is one of the most crucial things which I am going to talk about now, and that is work energy theorem. Work energy theorem, I am telling you with a lot of emphasis that work energy theorem is one of the most important concepts in the whole physics, because this concept can be utilized at any chapter, or in any chapter you can utilize this concept. So please try to feel this also, learn this concept also so that you are able to utilize it anywhere. So for example, you will see that in thermodynamics also you are able to use this. In electrostatics you will be using this. In EMI also you will be using this. So in many places you will be able to use this because you have all forces and their work done and leading to the change in kinetic energy. So I'll tell you what does it mean. So the theoretically I'll just first tell you what does work energy theorem says. Or you want to see it, you can also see it in the back. Okay. This theorem is saying a very simple line. It is saying in a given system or for a given particle or for a system, for a given system of particles, it depends upon where you are applying this WET or work energy theorem. It states that work done by all the forces, is equal to change in kinetic energy of that system or of that particle depending upon where you are applying that work energy theorem. So I can say work done by all the forces acting on the body is equal to change in kinetic energy of the body. Or I can say work done by all the forces acting on a system is equal to change in kinetic energy of the system. So please remember, it depends upon your choice of that thing on which you want to apply this work energy theorem. But please remember, when I am saying work done by all forces, meaning you have to take the work done by all the forces. It could be external forces, it could be internal forces to the system as well. Because there is a possibility that in some cases work done by internal forces may not be zero. So work done by external as well as work done by internal forces should be counted. There might be some conservative force in the question or there might be some non-conservative forces in the question. So you have to take the work done for these also. And one very crucial point, even if you apply this particular theorem in a non-inertial frame of reference, or I would say in an accelerated frame of reference, then in that scenario a pseudo force will act, because if you are making the free body diagram in a non-inertial frame of reference, the pseudo force will come. So don't forget to take the work done by pseudo force also in that scenario. So the point is, when I say work done by all forces is equal to change in kinetic energy, you can apply it anywhere in any frame of reference. You can apply it for any particle or any system of particles. So it is up to you. But be careful that all the work done needs to be calculated in that frame of reference. All the displacements, all the velocities have to be calculated in that frame of reference in which you are doing the question. So be very clear about it. Okay, so I will just say it one more time. Work done by all the forces is equal to change in kinetic energy of that particular body or system, whatever we are talking about. Okay, now how to write it, how to use it, let me tell you. So writing is simple. I'll just write like this. Work done by all forces is equal to delta K. Please remember, when I say change, it is always final minus initial. Final minus initial. Simple. No confusion. This all forces include all. It could be conservative, non-conservative, all. It could be internal or external. It could be your pseudo forces also if you are making in the FBD of or if you are doing this in the frame of reference of a non-inertial frame. Okay. So whatever forces are there, all the work done needs to be calculated in this concept. Be very clear about it. Let me take example to show it. Let's see. Let's say you have this block, mass M1 or mass M. Okay. It is kept on a smooth surface. To make life simple, just to make you understand things, you are applying a force F0 on this. Okay, initially the velocity is u. Now after some time, when it has displaced by some s distance, the velocity becomes v. So I want to write that work energy theorem on this particular system in the ground frame only. I'm doing, see, when nothing is mentioned, we assume we are doing in the ground frame only. Okay. So first point is, can I say our particle has gone from A to B? So points note, I am applying work energy theorem on block from which situation, initial to which final situation? From A to B. Okay, so what we are doing, we are applying work energy theorem on the block from point A to point B. Okay, now let us make the FBD of the block so that we can write the work energy theorem properly. So I am just saying for the FBD, there is a mg also acting on the block, there is a normal also. So I hope you realize, since it is on a smooth surface, there is no friction. I have not taken any friction into account. Okay. Now let us apply. So I am writing work done by all forces is equal to change in kinetic energy of the block. Because I am talking that applying this theorem on the block, be very clear. So I am writing half mv square, which is the final, minus half mu square, which is the initial. So k final minus k initial, that is the right hand side. Now what is the left hand side? So I have to write all the forces on this, or work done by all the forces. So I am writing all forces, work done by F naught force on the block, work done by gravity mg force on the block, I have to write at least, and work done by normal reaction. Now can you tell me, is there any other force left from the left hand side or in the left hand side that I have to use? Tell me, is there any force on the left that is left? I have written the work done by force F naught. I have written the work done by force of gravity. I have written the work done by normal reaction. Is there any other force that is left in this question for which I have not counted the work done as per my calculation or as per my expression? The answer is no. I have taken all the forces that are under consideration in this chapter, or in this question. Now I am claiming that the work done by gravity is 0 in this question and work done by normal reaction is also 0. Why is it 0 in this question? Because the force is in vertical direction, whereas displacement is in horizontal direction, and angle between them is 90 degrees. So that's why the work done by gravity in this question is 0, as well as work done by normal reaction is also 0. What is the work done by F naught? That is simple. F naught into S, and that too in the plus form. Why plus? Because force is in this direction, displacement is in the same direction, angle between them is 0, cos 0 is 1. So this is the left hand side. So I will write this here properly. F naught S is equal to half mv square minus half mu square. So you see, this is how we apply work energy theorem on a body or on a system of bodies or on a system of particles. Okay, so I hope you have understood these things and you understood how to approach these kind of things. Okay, so let us stop for now, but one thing which I am saying to all of you is that we are trying, or we will make sure that you will get to understand these things properly on this channel of Vedantu NEET English. Keep following us, keep seeing those lectures, and get a good rank in your NEET 2026. Okay, so let's stop for now, and I just want to tell you, we are bringing something for you guys very soon. And just keep following us. We will let you know. So it is still a surprise for you before we make that announcement. Okay. Chalo. So let's stop for now. Bye-bye. Take care. And thanks everyone. And we will be sharing all these notes. See, there are a few more questions in this, which you can actually see and you can practice. Okay. See, there are a few more questions. Okay. So thank you everyone. And keep learning, keep enjoying. Bye-bye. Take care. Any problems, any doubts, you can always reach out to me at @Vipul Arora Physics. Telegram ID is this. And just reach out to me. And if you have any doubts, please let me know. Bye-bye. Keep learning, keep enjoying, bacho. Bye-bye.